Grab a chair.
Yeah, you can stand.
Was it beanbag?
Yeah.
Just beanbag down the front and then relax. You can have a seat. You don't have to stand.
That's good.
Let's
Okay,
go.
good to go.
Okay, welcome everybody. I'd like to introduce today Ross Brown, who's kindly come down from QUT. He's a senior lecturer with the Science and Technology faculty. He also teaches computer graphics in the Bachelor of Games and Interactive Entertainment there at QUT. Ross's main research interests are in the application of 3D technology, in particular answering the question of how we can use virtual reality to enhance VR cognitive abilities. And today he's going to talk to us about monitoring through many eyes, spatially enabling people to protect the Great Barrier Reef.
Thank you very much, Thomas. Thank you very much. Thank you very much for the invite to come down to speak here. It's good to have Kingsley speak highly of me. Hopefully I will not disappoint today, but we'll see. But to get you warmed up, there's a picture of a nice turtle, which always makes people feel good about things. So anyway, yes, just a little bit more about who I am. I've spent 25 years teaching and researching in the area of computer graphics and virtual reality. It's interesting to me, John McCormick, because I can remember years ago when I was working at Latrobe Bendigo, looking at your web page, and you had a webcam poking out from an SGI workstation looking out over the Monash Point campus. So I've been around for a little while, but that was when I was teaching, and then went on to look at sort of games technology and virtual reality and research. And now I'm now course coordinator of the Bachelor of, that's a new one, just been given to me, of Games Interactive Entertainment at QUT, which we like to call the biggie. And I'm also a member of the Chi discipline at QUT. Some of you may know Margot Brereton, Professor Margot Brereton, who's fairly large in the Chi space. So as I said, this talk today is probably me just talking about some of the projects that I've been looking at addressing this main research question that I have, which is how can we use virtual reality to enhance the cognition of users. In particular, I focus today on memory. And I'm looking at, today we'll just be talking about some projects that we have going at QUT that are addressing this issue, but I also look at other aspects of mental effects. So almost, some emotional effects on particular sports people, behaviors with disability training, and so forth and so on. So that's probably where I sit. I moved from being a pure tech dude who wrote shaders and his own version of OpenGL for teaching and so forth, and I've now moved to looking at just what can we do with virtual reality and how that can affect the mental cognitive capabilities of people who use it. And in particular, I'm looking at knowledge elicitation. So today's sort of focus is about it's about projects that I'm working on, looking at trying to use virtual reality to get better knowledge out of people. Because this is a continuing problem. Knowledge elicitation and knowledge management continues to be sort of one of the bigger topics that people look at in IT. So to digress for a minute, I only recently joined the Chi group at QUT. For a few years, I was in an information systems group, which may be odd, but this was the paths that we lead, and some of them are winding. And the group at QUT is very heavily into business process modeling, whereby it's effectively looking at trying to map and model the interactions between humans and IT systems from what they call a process-aware point of view. In effect, determining when tasks are done, when people make choices, and when people do tasks in parallel. So it's like a visual programming for an entire enterprise. And so I was looking at sort of visualizing various aspects of that, which sort of has reference to some of the work you guys do here. I think Tim Dwyer does work on network visualization. So these sort of topics start to overlap, and I was doing some work in that. I'm continuing to do work in that. But it came up that sort of process elicitation is a bit of a problem for business process management. You have a business, it does things, but they don't know how they do things. They've got IT systems, they've got people, they mill around, and products emerge, and the company makes money or it fails. So the whole idea is, can we model this process, clearly show how people and IT systems interact, and can we then utilize that to refine the processes inside an organization? It's like time and movement studies, but at a larger scale. So I looked at, well, if you want to elicit information from people, it's interesting, the virtual worlds and virtual reality, lots of research showing that it primes memory and has some strong cognitive effects on people, in particular even their language, which we found with some of our results in the research that I'm going to get to. And this suited sort of the way some technologies and some theoretical approaches take to business process management, was sort of a subject, object, predicate approach. Fred uses a computer terminal to print checking information when he goes to the airport. Now, some people may think it's not so exciting, but there's a lot of businesses who need to know exactly what people do inside environments in order to plan effectively and resource things. And so this sort of approach, I thought, okay, with this subject, object, predicate, just maps to how you do things in a virtual world often. You wander up to NPCs, or so you as an avatar go to an item or an artifact in the world, and you do something with it, and that may push a game forward, that may push a simulation or training system forward, and in this case, we can use it to model processes inside environments, extract that information, and potentially get better models. So, and again, to sort of deal with this problem of stakeholder elicitation. How do we get models out of people who don't think in a process-inclined manner? So what we did, we just did a comparison, an A versus B experiment. I'm trying to cover this quickly because I want to get to the reef, but this is what inspired the reef work. So on the top left here, as the movie progresses, this is just a modeling system, the sort of thing the process modelers use. And in particular with this grammar, it enables you to show sequence and choice and parallelism. Funnily enough, this modeling technique approach uses sort of the transputer model of agents sending messages in a large distributed system. So they use that to produce these models, but the agents are humans and they have their own methodology, as championed by a German company called Metasonic GmbH from Ingolstadt. So, we built a modeling tool which suits their methodology, and that's great. And then we said, right, that's all good and done. And so here's an example, if I just push this video forward, of the final models that are generated that dictate how people interact in an environment, such as an enterprise in a business. So we looked at that and thought, why not do it in a virtual world? And so we built an airport, because you can do that sort of stuff in virtual worlds. And we set it up so that we got people to go around and we asked them, what is your check-in process? How do you do things inside an airport in order to get yourself from the entrance to be on the plane? We chose this case study as an experiment. This is just an exploratory experiment. We wanted to look at a process that everybody knows and is therefore open to sort of, people are experts in getting on a plane. So they have knowledge, and we can extract that information from them and get them to build models that the business process people would be interested in. So this is just a preliminary experiment in this space. And so we grabbed about 64 people randomly assigned, your typical 20-year-old university student. These people don't know about process modeling, so that's the whole idea. And they're experienced travelers, so they know about check-ins. And they have some moderate virtual world experience, which means they play games, and that's fine, so they're across this. So, once we'd done that experiment, the thing that was interesting was, so I won't bore you with the details, if you're fascinated by the details, is the DOI for the Information Systems journal paper we generated from it. But we had 3 hypotheses which were fairly strongly found to be true according to the statistics. First of all, we found in comparison to a 2D approach, virtual world people specify larger numbers of task steps. In the experiment, we primed them with a storyboard video to get them on the same level playing field, gave them a gap in time, and then said, right, now you regurgitate what you do to go on an airport check-in. And so even if they were evenly primed, and we found that most of the differences between the groups, same mixture of sexes, genders, experiences and so forth, so they were evenly primed, the people with the virtual world specify larger numbers of the original process, larger number of activities and choices than the original process that we showed them to prime them. Interestingly enough, they also created fewer erroneous task sequences. So not only more information came out, but it was more correct. But the bit that really got us thinking was, in the virtual world, they used a more consistent set of words to describe the tasks. So even with things that were not labelled, they actually didn't use as wide a distribution of words. It changed their cognition so that being in the virtual world narrowed the lexicon they use to a more consistent number, which business process people get excited about, because that means you've got a more consistent specification for tasks within an environment. And that's within that domain, all right? That's the sort of utility that business process management people are looking for. And that was great. Furthermore, we've kept this experiment up. It's a PhD student, and we just got a paper in AusChi about where we've then compared a virtual reality interface with a virtual world desktop system, and found that people were able to again specify more accurately and more items in comparison with the same even specification of the experiment between A versus B. And so it seems that even immersion has a stronger effect, again, on the ability of people to remember this. And there's other work that supports this, but not in specifying processes. Most of the supporting work is about just remembering things, the arrangements of objects in a scene, visual representations and so forth. So the implication from that was there's some potential effects from using virtual reality on affecting people's cognition, and in particular for extracting memory from experts, trying to get them to episodically remember what it is about a particular scene that fires their sort of knowledge schemas in their head, and they'll be able to emit potentially better quality information for any modelling tasks that we have to do. And so while I was doing these experiments, I had a chat with Professor Kerry Mengerson from the Australian Centre of Excellence in Mathematical and Statistical Sciences, and she's a big Bayesian modelling expert internationally, and they run a Centre of Excellence at QUT. And she said, could we do this for environmental modelling? And I said, yes, we can. And she said, great, here's some money, let's do something. So we launched off into looking at environmental modelling in a couple of case studies. So there are two projects we're working on at the moment. The big one is the Reef Project. This has got a bigger picture, but it's a bigger project because this is the one that's actually been funded heavily by the CRC for Spatial Information at QUT, the Department of Natural Resources and Mines in Queensland, and also the ASIMS Centre that Professor Kerry Mengerson runs. So we've hauled together a team to ask, to build a system to look at, can we use this elicited expert information to assist in building better models of reef health. Now it goes without saying, the reef's in a tad trouble at this moment in time. And this has been massively portrayed in the media, but the problem is there's a lot of hub going on. There are a lot of pundits, a lot of people doing jazz hands, worrying about what the hell is happening to the reef, and there's a lack of quality information. The classic is that in some circles, people have been reporting 90% of the reef is dying. That's not correct. It's about 24%, which is scary enough, but there's a lack of quality information out there. And so the idea was, what can we do to improve the quality of the information being presented to the public? How can we get better models by getting better information out of experts, is where the virtual reality comes in, and also how can we engage citizens in citizen science? So it's not just experts, but it's also the laity. We're trying to engage people in trying to get them to provide information that is useful to the statistical modelers to estimate reef health. And so this is where the many eyes concept comes in from the title. The idea that people can virtually go through the reef, provide expert or lay information about the quality of the reef at those locations from either UAV, underwater submarine scans, and so forth, and then that feeds into spatial statistical models, which will enable us to make some better decisions about these incidences of what is actually happening on the reef, because the reef is being monitored, but it is not being completely monitored, and there are gaps in knowledge. And so, in order to get that information, probably one of the most likely things that we can exploit at a very low cost is citizen information from dives that they take, or citizen information from them viewing data that is images that have been taken by submersibles and other equipment, or experts, people who may not be located on the reef but can provide expert information about the quality and health of the reef. And so the idea then from this is we get a number of outcomes using this. We get better engagement with the public because we're providing better models for them. We're also utilising their abilities and expertise on these projects. And we also get just better management, so that hopefully we can not see any further erosion of the quality of the reef. We hope in the future that these models will enable us to make some informed management decisions about what to do. In particular, for instance, the Department of Natural Resources and Mines in Queensland, they control land. Land runoff is an issue for the health of the reef. So they need to be aware of what's a good model relating land runoff of nutrient with coral reef health and all the sorts of factors that are occurring there. So a number of stakeholders, a $7 billion per year asset for the Australian economy, and so there's lots of people who need to know precise information, and so this project is seeking to contribute to that by developing a citizen science framework. So the project came about because Kerry Mengerson, effectively my boss on this project, and the Department of Natural Resources and Mines and the Spatial Information CRC all got together and discussed the idea of, well, there's a lot of sort of sample data out there, but first of all, the spatial modelling is not quite leading edge, and so this is where Kerry Mengerson's knowledge comes in with the Australian Centre of Excellence. And also there is a lack of framework to allow citizens to directly contribute. Here are my images, and I can give you some information about those images that you can feed into your models. So the project is not so much about virtual reality, but it's heavily used in that. It's more about creating spatial predictive models of reef health. That's the basis for what we're getting up to. And the virtual reality tools are used in order to produce, we potentially believe, produce better data for the spatial statistical models. The other goals we have for this project are to engage the community in monitoring the reef. So the idea is that people can get some engagement by providing information into the system. Probably our biggest two novelties in this work is developing some novel visual experiences of the reef that go beyond just providing 360 immersive video or imagery, but looking at creating some interactive experiences there for people to provide expert information. And then our goal is, well, we're about to do this. We're going to go up to Townsville in a couple of weeks' time, and we're going to get a pile of divers to use our system. We're going to actually validate the approaches and extract some better spatial models and check that this system actually works properly. So this is the sort of the goals of the project, and the basis of it is as I said, modelling. So here's Heron Island for those who haven't been up north. Heron Island is a fairly heavily studied sort of island with a reef architecture, for want of a better word, and a number of studies have been performed across the area of the island. So we can see here that there's been research done and what are known as transects done of the reef in 2007, 2012, and also the Catlin project from the University of Queensland, our august cousins up the road from QUT, have also done some work there. And what they do is they get a submersible device with a 360 camera with a diver behind it driving along underneath the water, taking imagery of the reef as they go. And these are the transects they perform across various regions of the reef. A couple of things to note: it's very expensive to do this. So monitoring the reef with this technology, while effective, because we haven't got the computer vision systems quite yet to do all the things we need, you still have to have people on the ground looking and sampling and taking imagery. And as you can see, well, you know, they've covered this end of the island well, and a couple of transects through here, but the eastern end of the island is left blank. Now, there could be a number of reasons for that. It could be dangerous. It's actually hard to go around the reef in some places. But also, it could be just we ran out of money, got that far in, and couldn't quite get to the eastern side of the island. And in addition, they haven't simply got to that place yet. So the modelling seeks to fill in this information from the expert knowledge that's elicited from the transects that are already set up. So our boffins in the mathematics department have built a coral cover prediction model for Heron Island based upon this present data. And it predicts that, of course, the reef, based upon these initial values from the transects, they build a model based upon those transects. And then they take that and apply the prediction over the reef with a related error. So they're saying the darker errors, so the darker areas have less error than the lighter areas going onto a sort of mauve colour here. The model performs quite well. It's been expert validated by divers and scientists on Heron Island. So yeah, this clearly reflects the way the reef's coral works. But there's still a lot of error in the predictions over here. From the model predicts that we have a lot of lacking information over here. So these models can be used to drive people to go diving and provide further citizen information. So the idea is that the many eyes could go to those locations, and instead of relying upon government-funded resources, people can go there, dive, submit their images, experts can elicit the knowledge, and we can produce a better model at this region, get a better, more accurate model of reef health, preventing all the spurious claims that sort of go around, getting a real claim for what is the health of the reef at any point in time. So that's where our project comes in. So our project seeks to provide these models. So the virtual reality is used to provide better models. And it's made up of a number of components, our system. So we have a spatial modeling component driven by various large R scripts running on a cloud system that we've developed. We've also provided a web interface for citizens to provide their imagery, fairly standard sort of stuff, but still it feeds into a human-computer interaction component because we're trying to engage citizens in getting in and providing information. We provide some virtual reality experiences for elicitation, which I'll show you in a minute. And I also have the elicitation interface available here on a Gear VR, if you wish to have a look at it later. And a complete workflow framework which ties this all together. So the idea is that it's the real contribution to this space, along with our virtual reality and our spatial modeling, is also tying the whole thing together, a synthesis of a number of components that haven't been sort of done before in a really thorough manner. And we're providing this entire framework to enable us to do something effective and enable citizens to contribute to an understanding of what's going on the reef. Also, it's a nice general framework. This applies to many other applications in environmental modelling where you need to elicit expert information from people. So what is the system? Well, here's a movie that I'm about to go through to show you now. So here's our website with a map-based, you've probably heard of Cesium. It's a 3D environment for showing GIS data on surfaces, which has a virtual reality component. If you press that button here, you can go in and cruise around on the surface of the Earth. This is Heron Island, and we can see here that we've got some tags here where data and imagery has already been loaded, and then we can, through our system, show the model over the surface. So again, the model is centric in this process. So that's the reef cover, and I think in the next couple of seconds I go down to here where I start to show, while I was doing this, just where the error is in the reef model. Now, this enables any management people or any citizens to understand where they may wish to dive, but also for the government to say, well, we know we've got a lot of data on this end, but maybe we should be looking at the eastern end. Can we get it from citizens? Can we fund it? So it assists us in this sort of modelling approach. But this data has to actually be uploaded by citizens and queried. So the idea is that we provide a complete interface on the globe that enables people to query at each location what they've actually uploaded and what other people have uploaded. So this provides a basis for the system for a community. Note the QR codes. The QR codes provide the interface to our VR experience. They're auto-generated upon any uploading of an image to the database. So if you want to, you can go through the images that people have looked at. Fairly straightforward interface, and that's all fine. But in a minute, as the video goes through, we start to look at how actually people will load it up. In fact, I might even fast forward over this, because for this audience, I prepared this for a government audience. So this shows a 360 camera. People can easily log in. There's a whole user curation that we go through, because people might upload unsavory images if you let them. So that was something we had to sort of suss out. But here we see, actually I might let it keep going. Here we see that a person who's loaded up that image then provides this citizen information. Okay, they're going to load it. Bang, there's the map. One of the problems is that images taken underwater don't have GPS information attached. So we let the person position where they took their imagery information, and once that's annotated, the person can then go through and look at some basic questions, which enables them to say, okay, I took that imagery at that location, and did you see any crown of thorns at that location? Did you see any coral bleaching? What depth did you go to? What was the temperature of the water, and so forth and so on. So along with that information being uploaded, people are able to provide some meta information. Again, fairly straightforward sort of citizen science stuff. And then our trained orcas loaded up onto our back end. And again, there's that QR code, which I keep harping on. And that's a surround image that's been loaded up to our framework. So moving on from there, somebody might want to come in and go, oh, I want to have a look at the reef at a particular location. So they can go back to the interface, bring up an image, and this is where our funky VR experience comes in handy. You point the camera at the QR code, and you end up being inside the reef. Now we have two experiences. One's a sort of cut down, just to have a wander around and look inside the reef from each of the 360 locations. Or you can have a grizzled VR reef expert wander in there and actually do some elucidations, which I've got here on the Gear VR that I have present. So without further ado, we'll leave this bearded gentleman behind, and we should then be taken into the environment about now. So it's sort of a fairly straightforward space. We've incorporated some interactive elements with the imagery. The idea is you point this at a QR code, and for an initial interface, just for this demo, we show that you're given a set of spatially distributed samples in the sphere, and your job is to classify those locations. So this is from within the app, so you point at the QR code, bang, you're in that location. And then from there, there's the circles that specify, we want you to classify this region. So some computer vision systems still struggle with a lot of the detail of trying to classify areas of images in the reef. Because it's a random distribution, we have to classify things as water. That's just the way our interface is at the moment. We're going to refine that in due course. So once an expert has classified or laity has classified those elements, they submit those pieces of information back to our framework, and then if they wish, they can have a look at another image. But then the idea is that once they've sent that information back, the statistical model in the background grinds away and says, oh, coral cover's not so heavy in this region, and it updates the model. And so this sort of framework enables, government departments or various sort of reef stakeholders to be able to monitor using this citizen data. By the way, we also have 2D interfaces for this system as well, because not everybody has a 360 camera. But we're not only looking at the reef, so we're doing some very similar work. Just keeping mindful of the time. Very similar work with jaguar population estimation in Peru. Again, the same problem comes about. There is an endangered species, the jaguar, Pantera, a lovely creature which has had its native habitat sort of eroded by logging and farming. It's an endangered species, and the idea is, well, they don't really know how many panthers or jaguars actually exist in the wild. They have sightings, they do some expensive but very small scale estimates based upon regions. So far they haven't been able to incorporate citizen data into these models, and therefore they're not really sure, well, how well off are the jaguars and whether they have an understanding of where the jaguar are moving. Because one of the things, of course, that is a problem is humans still want to live as well in the regions that are next to or within jaguar territories. And of course, governments and various stakeholders have to plan for this, so they want to leave jaguar corridors available for the animals to move between their various locations. They're a territorial animal. There's all sorts of issues around providing enough room and enough habitat for them. And so modelling that is a tricky problem. So this is the other project we're working on using a similar approach. The idea is that sort of late last year, a few intrepid members of our group, this is June, she wandered off with a group of researchers over to the Amazon in Peru, and they took a pile of 3D cameras with them to sample regions and sample particular areas of habitat for later elicitation by jaguar experts. So there's a number of factors to think about in this project here. Of course, the reef is much better resourced as far as obtaining information, but there's still gaps of knowledge that require citizenry effort. Here, it's even more important that Indigenous populations are sort of drawn in and enabled and facilitated to be able to provide information that is useful to experts for the modelling purposes. So the idea in the end is that we wish to leave with the local Indigenous populations and other stakeholders in the area some cameras for them to wander around and take monitoring images of the area, upload that via satellite link, and then when they go to a particular area with internet access, and then population experts in other countries or in other regions of Peru are able to look at the 360 images and judge effectively whether there's a panther present there or not, or a jaguar present there or not. So this was imagery taken from a trip late last year. Kerry has also gone over there and is just about to fly back. I believe when I get back to Brisbane, she'll be ensconced in her office again. So we have a second amount of data taken from our trip up the Amazon. So the project it's similar to the reef, except we're doing a bit more here. We're using somebody else's data in the reef project. So all those 360 images I show you are from the Catlin project run by UQ. They've kindly let us use the data for our purposes. Here we're actually going over there and trialing the idea of, well, can we get effective 360 immersive virtual reality style images that we can use for expert elicitations. So here's a sample. This is an equi projection. So I don't have any jaguar data on the Gear VR here at the moment, but we took the GoPro imagery here. June sat down in her office and has stitched it all together. And so these are the sorts of images that are presented to experts, and they are able to figure out from this whether there may be potentially jaguar present. Particularly, they look for things such as tracks in the environment and how the jaguar leaves any sort of telltale signs of its presence. They may be able to perceive scats left behind by the jaguars. But also, one of the key things as an indicator of a jaguar's presence that an expert will pick up on is whether certain plants are available for herbivores that the jaguar will like to eat. So this is one of the covariates that the group uses in its modelling. They simply say, I don't know, I'm not an expert, but if this plant represents a capybara, eats that, and the jaguars like to eat the capybara, then you've got a chance that the jaguars might be more likely to be in the area than if you go to a more desertified area, or you go to an area where it's obvious the capybaras wouldn't live. There's the sort of reasoning that experts will use, because jaguars are, of course, being an apex predator, quite hard to find because they're shy. They do wander into villages now and again, apparently, and then they wander off. So they're not sighted regularly, but that you can hear them, and apparently the team heard them in the distance. There's a particular call they make, and they knew there were jaguars around, but they never saw any on their trip. But we know that if particular prey are present, you've got a higher chance, probabilistically speaking, that jaguar are present. So again, using the Gear VR and this 360 imagery, the idea is that the priming of being immersed in such a way will enable more effectively an expert to get an idea about whether the prey and or a jaguar are present in this region. In particular, because it's much more spatial, you're able to look around, you're immersed, and as far as we can see from our preliminary experiments, there's a strong effect of this. And in addition, it requires that immersion to, we believe, it requires that immersion to reason about the structure of the forest in that region. So this is where the virtual reality comes in quite useful for enabling an expert to make sense of the structure of the forest in that region. So from this, an initial jaguar presence and absence model has been generated. And we've just pumped out a paper on this and sent it off to a journal, Environmetrics. We'll see if that's successful or not, see how we go. So this work is just starting to mature. That's on the first lot of data that we got back from the first trip. The second trip, which the people will be coming back, will do further analysis and get some more experts to look at the data to produce their models. So we put a pile of experts, I believe about 10, through these 360 images, and then applied some complex mathematical modeling, which will be heavily Greek and is not my area of expertise. But this is just a sample from the paper, just to show you the outputs of what the models generate. So we can see here that there's a comparison here between predicted and observed locations, and the idea is that they've tried 3 methods. So there's support vector machine, a logistic general linear model, and a beta distribution model across a region of the Peruvian Amazon jungle. And the green represents a predicted area where the jaguars have been present, and then there is our observed locations where local people have picked up on the presence of jaguars. Now, the idea is this is essentially a form of ground truth. So we could, we think from observations, yes, jaguars are around in this region, so our model's able to predict that. But the idea then is, based upon elicitations of the terrain and data in that region, we can start to try and predict in areas where there are no observations. So remember from the first reef model that I showed you, the Catlin project has sampled all these regions. It's very expensive, they can't do the whole reef. So we try and build a statistical model which gives us information for the rest of the region based upon expert knowledge. So this is just an initial foray into doing the same thing with jaguar presence absence. And the idea is, of course, that again, we're utilising this 360 imagery in order to provide what we believe is a better interface for the experts to be primed and to elicit from them their knowledge about the presence and absence of the jaguars. So, I think, where am I up to? Oh yeah, I think I've come to a good point, so this times well. So in conclusion, just to draw out to some of the outcomes from this and some of the intentions. So we see that from initial experiments in sort of virtual worlds and business process modeling, we got a hint that expert and lay knowledge, there would be some utility in using virtual reality approaches to prime people's memories and to and knowledge schemas and get them to emit data better. So our process modeling results are reasonably strong. We're yet to see how our environmental modelling works out, but we're just early days because we've got this data just coming through now. So as I said, our reef modelling approaches will validate very soon, and we're just getting through our data for the Amazon work. So you're the first to hear about this. The idea is, though, of course, we believe that these approaches will enable us to get lots of data out of citizens, especially with our reef project. And that will help us in creating better quality models. And in the end, even though I'm a virtual reality sort of expert and technologist, it serves the purpose of creating better models in this case. So the use case is about getting better models. And we think that these sort of frameworks will be able to engage with citizens better. So we're just in discussions with other stakeholders about scaling up our framework and seeing how well it does in an environmentally valid test with the actual general public. So we'll see how that goes. And we've built like a proof of concept web-based platform to gather citizen data using this unique VR approach. And we've also developed some initial spatial models both for the jaguar presence and for the reef coral cover. We've also enabled citizens to have a virtual reality experience of the reef as well. So we'd be able to see whether there's some directions to take in that area too. I've been focusing on expert elicitation knowledge, but there's another aspect where we're looking at whether providing some of these experiences for people will draw them more into wanting to assist in the managing the reef and bringing it back to a better state of health. So moving forward, we need to do some deeper validation of these approaches. So as I mentioned, we're going to be going up north to Townsville to do some tests with our interfaces and making sure they're usable and they have a strong effect. And also upon the data from the recent trips to Peru. And then we're going to take this whole model and scale it up to the whole of the barrier reef. So we've been doing some tests around the Heron Island data. So there's about 3,000 reefs on the Great Barrier Reef. It's not a continuous reef. There are areas where, of course, there are no coral growing, but there are identified 3,000 reefs, and so we're looking at how we can scale our model up to work across the entire Great Barrier Reef. This is where we need more citizen data. So this would be where we would need to create a sort of a community around this interface to say, hi, help us identify things in the reef, provide us with knowledge about this imagery. We can't do it automatically yet. But also this approach, as I've shown, we've applied it to looking at jaguar modeling. This also applies to other sort of preservation ideas, including waterway health. So we're looking and doing that with the Department of Natural Resources and Mines in Queensland. Invasive species, identification of particular pests, taken from photographs, get an expert to look at it, feed that into a model, a spatial model. Issues around urban development, getting experts to look at how suburban or urban development or peri-urban development is affecting local environments and the quality of life in that area, amongst others. And finally, just expanding these sort of ideas to creating communities of purpose around engaging citizens to provide more either lay or expert knowledge into these models using such interfaces. So that's the end of my talk, and if anybody's interested, I have the app here running on the Gear VR. And thank you very much. Are there any questions?
Questions for us? I have one.
Okay. Yes.
Thank you for the talk. I think it's a really interesting topic, and I really want to know, how did you measure the engagement of the experts when they are label their images? I mean, did they label the image more accurately, more efficiently, or do they feel more engaged, excited when they are labeled the images?
This is what we have to establish at the end of this month.
Oh,
so
okay.
Our experiments will be done up in Townsville with local divers, local reef experts. There's one of the sponsors of this project is the Australian Institute of Marine Sciences. So we'll be going there. There's about 50 of them there that we can test it with, and we've got a complete experiment ready to get some sort of experimental idea of whether it works well in this domain. So we've built the approach, we've built the statistical models. Now we need to validate whether this method works better or the same as 2D models. And as you say, some qualitative aspects around whether they thought it's a much more powerful method to use, or they're much more engaged and so forth. So we've got an entire questionnaire with a large set of questions to throw at them. We haven't validated, we've validated the approach with the process elicitation. So based upon that, we're trying to see if it generalizes across to the environmental modeling.
Great, thank you very much.
No. Yes.
Ross, how many for the Great Barrier Reef project you've got? How many citizens are involved so far? I mean, what stage of deployment?
No, we haven't had a chance to deploy.
Yeah.
So I'm showing you what we've done as a prototype system.
Okay. Yeah.
And so now we're just sort of, we're already engaging with a couple of groups, such as the Great Barrier Reef Resource Management Authority, the Barumpa, which is an odd acronym, and there's also the Reef Foundation, which is a large sort of not-for-profit organisation that gets philanthropy to support reef research. So what we're planning to do is to get more resources for them to look at an ecologically valid study. So we'll have a closed beta, which we're running towards the end of the project at the end of this year. So that project started at the start of this year. So we've written a paper, and we just want to get this information out there to canvas, and get people collaborating with us. But yeah, so we're hoping that once we get some positive results, fingers crossed, positive results on that, we'll then be looking at, can we do something at large scale?
Sure.
Yep.
I mean, from similar or similar projects, what are your estimations on how many people might be contributing to this? In the Great Barrier Reef, you've got.
It's a good question. The interesting one is there's a project called Snapshot on the Serengeti. And Snapshot on the Serengeti was another citizen science project. It had no VR or anything else. It was just standard imagery taken with infrared sensors, picture traps. I think they're called picture traps. They leave them up on trees and just capture images as animals go by. They don't have the methods to automatically classify them, and they have a number of million images which they couldn't classify, and they needed help. So they set up a website. There's actually even the frameworks out there for doing this at a fairly low level. And lo and behold, in 2 weeks, they classified all the images. And this was just people logged in and said, that's a hyena, thank you. And that was added to their models. And I think now this is very recent. So if you go to the website, we went to the website a couple of weeks ago while we were discussing this. And they said, thank you, we've got all the data we need, we're now grinding away and building our models. So it'd be interesting to go back there. They might have some fairly strong statistical spatial models of presence of hyena, wildebeest, lions, giraffes, and so forth. So we're thinking it seems valid. It's one of those classic crowdsourcing projects.
Yep.
People are motivated towards the reef, so we need to validate our methods to see that they work well. then we think the next step is, can we curry favour with the citizenry and get them excited about it, and then contributing to our models for further management. Yep.
Have you thought about any, you mentioned it on the last slide, any kind of game design paradigms to further excite people?
Yep.
So kind of shudder to use the word, but gamification.
Yeah, it's an awful word, I
It's a
agree,
terrible
but it's the
word.
word that everybody uses, so
Yeah.
we just go with it.
Yeah.
Much like pop music. So one of the classics would be, could we build a treasure-seeking sort of model, whereby look for the nearly extinct green turtle species. Here's some training images, here's some examples. All right, you have now got to level 10 and you're capable of going out into the reef data and finding the green turtle. And then, then you'll create a community around that, say, oh, here's an A10 level, green turtle finder. I mean, there are some issues around this. So that we have some metadata on things like, crown thorn starfish. But there's a particular project looking for an endangered species of manta ray, and that's what they do. They just pump out images and say, "Can you find a manta ray here?" And then you report that back. So I think that's the model that I have at the moment in my mind. It's not a priority at the moment. It's just that was in the conclusions as we could take this direction. But it seems from the snapshot on Serengeti, people are pretty motivated about wildlife anyway.
Yeah.
And there's also some problems with gamification whether people are going for the prize and don't do the job properly. But I think it's a worthy research task.
Yeah.
We could probably throw a PhD student or two at it and just see what they could do to turn this into a gamified sort of system. Yep.
Ross, I was going to actually ask, going forward with this, and I was thinking of those images you showed of the Peruvian jungle habitats and experts looking at certain species of plant to determine whether the prey is there and the predator is there, and then you're talking about jaguar calls. But is much further along in this research, is there an accommodation for how sound could be recorded?
Yeah.
And could you elaborate on that?
We haven't thought of that. We're only doing visual stimuli at the moment, but I think that would be
because say with invasive species and stuff, you'll often hear particular birds or
correct.
insects that might be invasive.
It's up to the spatial modelers, so they just add that as a covariate, and then you could put audio in. We actually have a research group at QUT who have a farm, there was a farm that was bestowed at QUT and up the north of Brisbane, and what they do is they've got lots of audio capture technology around, and they've been working very hard. They had a paper in Science just recently about this, just audio identification of bird species, and then being able to model how many of these birds are in the area. Do we have the presence of invasive species such as the Indian myna and so forth? What's happening in that space? So the answer is yes. It's just a matter of resourcing and adding that to the list of covariates in the model, and then the sighting would turn into, at night I heard the jaguar at this location. So it'd be interesting how you would elicit that knowledge. So you'd have an Indigenous person say, yeah, well, I was here and I thought I heard it from over there. But it'd be interesting, I'm no acoustics expert, it would be interesting how you would model that, which direction did they hear it from and so forth. Whereas sightings are fairly definite. It's like, oh, there's a speaker in the corner of the room there, because you can point to a location. That's like an episodic recall. Interesting question. Yes, it could be done. We haven't done it at the moment in time. It's all visual.
Okay.
Yes.
Yeah, regarding your citizens' data, I think all those metadata, location, depth, and temperature, they are very useful for the scientists.
Yep.
What about the GoPro videos without any image processing? How can you utilize that data that they upload?
Well, this is what we so we've sort of focused on looking at VR effects, because this is like a research project, so that's the new knowledge. But there's some fairly common usage of just standard 2D imagery from a GoPro and eliciting information from that, and our implementation has that capability built in, so people can submit GoPro imagery and allow that to be analysed by experts for presence of information. There is a project called XCoral, which looks at trying to understand images using recurrent neural nets and the sort of the deep learning approaches. Does okay for, say, picking up textured regions, but it still struggles with anything that might go to a higher semantic level that humans would deal with. And one thing I didn't actually mention is that part of our testing, what happened there? I must have gone out. All right, doesn't matter. Part of our testing that I mentioned, yeah, okay, that's on that slide there. Part of our testing, we're going to actually assess reef aesthetics, because one of the correlations they found is that the aesthetic quality of the reef also is a potential indicator of its health. And at the moment, humans can assess aesthetics. So we have a questionnaire containing various interventional information that we can then use to assess the quality, aesthetic quality of that area, and then build a spatial statistical model of the aesthetics of the reef based upon those predictors. So, but we can't use computer vision for that yet. Getting a computer to say this part of the reef is beautiful and this part of the reef is not beautiful is a problem. And so we ask questions like, would you dive here? It's an interesting one. I mean, because I'm not a knowledge, my area of research is in VR, but these people who work with their statistical modeling are looking fairly strongly at issues around, fairly high level responses from people and using that as a covariate to their spatial models. So hopefully I've answered your question, but so we can't use computer vision yet. They're starting to look at it, and there is some work out there on recognizing fishes and so forth, but understanding the higher level ideas about the quality of the reef is what we're looking at now, and we don't know of any automatic methods. So you've got to get humans to look at the images. And by the way, let me continue, that's where I think the VR comes in as well. Because one of the things I should mention, maybe because I have to rush through this, is the recall of the quality of the reef is often tied to your embodied memory of that space. There's a classic experiment where they got people to recall, for some reason, their dental appointment. Okay, and they found if the person leaned back into the chair, they're more likely to remember details about the dental appointment because they're placing themselves back in the same situation. So our hypothesis is immerse a person in this environment and give them a diving experience, and they should better be able to assess the reef aesthetics compared to looking at a flat image. One of our research questions from the data that we're looking at. Yeah, no.
A question about the Elite's work that you showed in the process modelling. So you had the hypothesis there that in the virtual space, people's lexicon to describe things was smaller.
Yes, yeah.
Why do you think that is?
It's preliminary work. My hypothesis is that it's a priming effect, and that because a brain is like a very associative matrix sort of effect. Yeah. We're more likely to say the right word if the image of the thing is plunged in front of us compared to, what was that thing I interacted with? We're trying to use our memory, and that starts to get vaguer and vaguer. The priming's not as strong, so they're not as certain, or they're not, they just head towards various other words to describe the episodic memory.
Do you think it could also be because the imagery it's not super realistic, it's like it's CG kind of real-time stuff, and so you tend to sort of use more simplistic language with simplistic images, in a sense, or there's less ambiguity because the shape and detail is really focusing on things like the archetypal shape. There's not a lot of sort of superfluous textural detail that might lead you to sort of embellish it with more. I don't know. I'm just guessing, but it seemed like a really interesting result.
We thought it was an interesting result too. That was the one that got me thinking. Another interesting result that I didn't cover there was also the virtual world enabled people to remember things from outside, remember things better from outside of the primary visuals we gave them. So like I said, we started them off with a video to just say, this is your ground truth. This is a check-in process. gave them a rest to let it sort of settle in their head and disappear, and now regurgitate that. The interesting thing was, if they used the virtual world, they started hauling in things they remembered because they were primed by the environment, things that we hadn't put in the original video. So I'm assuming it's a similar effect there. And it seems that, from my reading of memory and chain memories and so forth, having that prime just produces all these other sort of primed terms in the person's head. So I'm guessing that, they head towards the standard word for that thing, and they don't flounder around trying to describe it with their own words, and so their lexicon just snaps to being a bit sharper. But it's just an interesting result. We have to look at it further. It simply prompted us to think, so something's happening to the person's mind from the priming. But it's similar to work done by some Dutch researchers, either at Utrecht or at Twente, I can't remember exactly, but they got people to use a virtual world with an avatar, and they would prime them. So imagine I'm the avatar, then they would just prime them with images behind them, which were related to the topic of conversation. The interesting thing was that the people's chats automatically headed towards the primes, even if the topic was off camber. But oddly enough, they thought the NPC was more real because of the primes. So they sort of just having this imagery can affect your cognition in very odd ways. And so it just opens up this idea. Like my overall research question is, so how can we use synthetic realities to start affecting people's cognition? So it's just an interesting topic, yeah.
Okay, I guess that's it. Thanks again, Ross.
Thank you very much.
And we should have a play with it.